Welcome back to the last example of the sum and difference identities. This time we're going to look at using some of our special triangles to help us solve this question at the top. So we've been asked to find the exact value for tan 5 pi on 12. 5 pi on 12, you're asking yourself, well, what is that in a degree form? Well, we can work this answer out. We know that pi is equal to 180. So I could write 5 times 180 over 12, which is the same as, what have we got here, 75. So therefore, tan 5 pi on 12 is the same as tan 75 degrees. And what we've got now is we've got a question similar to what we had last time, but this time it's now in tan. So let's now work this answer out. So we have tan 75 degrees. Well, this here can be broken up into different parts of values. So we can break this up into 30 plus 45, because that will give me that 75. And now I've got something I can use for a tangent identity. So let's work this answer out. So we would have tan 30 plus tan 45. Plus, because we're using the top part. Over the top of, well, 1 minus tan 30 times tan 45. So now I'm using this identity here to help start solving this out. Now we come back, well, we need to work out what is exactly tan 30, what is exactly tan 45 in terms of coordinates, and do the same thing in each case. So we can work this answer out here and say, well, tan 30, let's look up here. 30 up here. Tan is opposite over adjacent. So here's your 30, there's your opposite, there's your adjacent. So therefore we get 1 on root 3 plus tan 45, well here's 45, it doesn't really matter, opposite over adjacent plus 1 over the top of 1 minus, well we know tan 30 was 1 on root 3 and we know tan 45 was just 1. Now we've got a fraction as our numerator over another fraction in its denominator. One way we can get rid of this is by multiplying this fraction out to make this common. So I could say, well, let's times this here by 3 on both sides, and we're going to do the same thing down here. And what that does is now I get an answer of root 3, these two across cancel out, plus 1 over, now we can leave this here as 1 minus root 3, but we can write this here as, instead, root 3 minus 1 by just multiplying through the negative. And this here is where we're getting an interesting format. Remember when we started looking at functions, if we want to get rid of a square root in a denominator, we have to take a conjugate. So the conjugate is the opposite power, opposite sign to what's happening in denominator. So we're going to times this here by 3 pi plus 1, and whatever we do to the bottom, we're going to do to the top as well. Okay? So we're timesing the top by 3 pi times plus 1, root 3 plus 1, and the bottom by root 3 plus 1 as well. If we multiply that out, root 3 times root 3 is 3. Root 3 times 1 is root 3. 1 times root 3 is root 3, and 1 times 1 is 1. All over the top of root 3 times root 3 is 3. Root 3 times negative 1 is negative root 3. 1 times root 3 is positive root 3. And 1 times negative 1 is minus 1. So we've kind of expanded it out by using that FOIL technique. We now can start collecting like terms. We've got 3 plus 1 is 4. Root 3 plus root 3, well they're the same, so I have 2 lots of root 3. Down the bottom, again, let's cancel down. 3 take away 1 is 2, and these 2 should cancel out. So now I'm at a point where I have a possible solution. However, we always want to simplify the question. So we can simplify everything by 2. How many times does 2 go into 4? Well, it goes in 2 times. 2 into 2 once. So therefore, my final answer for tan 5 pi on 12 with the exact answer would be 2 plus root 3. All right, we have looked at all the identities. Identities help us to solve questions. Without these identities, there's no way we would get this exact answer as easy. Okay, we can see that we can use identities with our unit circle calculations, with our running our special triangles. But these here are very powerful. You're going to use them a lot more now that we understand them and we've seen them. They're going to make life a lot easier for you when you're solving with trigonometric equations. All right, I hope you had lots of fun. See you next time.